All right, I'm going to talk about graphing quadratic functions. This is page 28 in our notes. And a quadratic function will be a graph of a parabola. And the big thing when you start a question like this is, how do you graph a quadratic function? It really depends on the form of the equation. If it's in a form like this, we either call it, sometimes it's called a vertex form, but it's mostly called a standard form of an equation. You can graph it with transformations, which we learned in chapter 1. Start with a parabola, move it around, left or right, up or down, flip, compress, stretch, anything like that. If it's in this form here, then you are unable to do that because it's not in standard form, it's in general form. And with this, we're going to use the strategy where we're going to take this form and change it into this form, so then we can use this strategy. So this one we're going to graph using transformations. And the transformations are when you start with the parent function. Here it would be y equals x squared. And then use the properties of function transformations to move the graph. So this would be right 1 because of the 1. It would be down 8 because of the 8. And it would be a vertical stretch with a factor of 2. And so we'll graph that here. My vertex would be at -8. Sorry, that's a -8. 1, -8. And my vertical stretch is a factor of 2, so from here I go over 1, up 2, back to the vertex, back 1, up 2, back to the vertex, over 2, up 8, back to the vertex, back 2, up 8. And this is all a review concept from chapter 1. So I went through that kind of quickly, but that was something that we studied before. If you're here in general form, we can't just pick out the vertex like we did here. We said, oh, 1, -8 because of these numbers here. We don't have that here. So what we're going to do is change into standard form. Using a method called completing the square. And completing the square is going to allow us to change this into this and then graph it the same way. So when you complete the square, the first thing you need is the x squared to have a coefficient of 1, and right now it has a coefficient of 2. So we're only going to look at these first two terms, and we're going to factor out a 2 because there's a 2 in front of the x squared. Now I'm not going to worry about the 16 because that is going to be outside of my problem. I'm just going to do the first two terms. So when I factored out a 2, I got this. And when you complete the square, you're going to leave a blank because that's where you're going to do the completing the square part. I'm going to pick a number to put in that blank. I have this plus 16 that's kind of hanging out on the end, so I'm more focusing on this part. Now, when you complete the square, what you're looking for is a number here so that when you can go and factor this, it factors into two identical factors. Identical factors are good because then you can write them as one factor squared. So how you get this number is you take your b value, your -6, and you divide it by 2 and square it. That is going to give you the magic number to put in here so that when you factor, it factors perfectly. -6 divided by 2 is -3. -3 squared is 9. So I added 9. In order to make my equation unchanged, which I want to keep it unchanged, I don't want to change the graph, I would need to subtract 9 right away. But because there's a 2 out here, although I added 9, if I distributed this 2, the 9 would turn into an 18. So I need to negate my positive 18 with a negative 18 at the end of the equation. So I'm going to clean this up a little bit. I'm going to factor what's in the parentheses into x and x, 3 and 3. It's a negative, so negative and negative. I'm going to write my plus 16 minus 18 as a -2. And then now how we have the x minus 3's repeated, I can write it as x minus 3 squared. So that now we wrote it as 1 squared, and now if you look, now this is in the standard form, so we can use our graphing with transformations idea here. So my vertex is going to be over 3, down 2, and again a vertical stretch of 2. So over 3 down 2, over 1 up 2, over 1 up 2, over 2 up 8. And again, this graphing is in section 1.7 if you need help reviewing how to graph using transformations.